The next question is question number 4. Which says, draw the simulation diagram from example 4 into Simulink. Run a suitable test. Okay, so let's have a look at example 4. There's example 4. Okay, so I'll give you some ideas of how to put this into Simulink. We're going to keep B and K the same as before, so it's 0.3 and 2. And I'll show you how to put this into Simulink as a simulation diagram. I'm going to keep the step input and the scope there because we will need them at some point. Might need to move a bit of space. Okay, so looking at the simulation diagram, we have a integrator here. Integration is the opposite to differentiation, and the formula for that is 1 over s as a Laplace transform. So we'll go to the library browser, and it's under continuous, and you'll see an integrator, 1 over s. Drag that in. That is my integrator. It looks different here. It's an integration symbol on the tutorial. So the output is y. We're going to look at that with the scope. Then we've got 1 over b. 1 over b is a gain. So you will find that under the math operations. So math operations, and it's just a multiplier gain. It looks like a triangle. It takes the input, multiplies it by the whatever the value of the gain is, and then spits out the output. So it's 1 over b, so it's 1 over 0.3. So I can just click on that. Now if you just see a k, if you want to see the actual value, there you go, you can just expand it a little bit. And that one is connected to that one. Okay. We have a subtractor block. So let's put the subtractor block in. Subtractor block, you'll also find it under math operations. Looks a bit different as well. Of course, it's just about getting used to how these do look a little bit different here. So you've got the plus on the one side, that's my input, and I can connect that to that like so. So I've got my plus, minus, and the output here. What goes into the minus is K, and the signal flow is going from right to left. So it's another gain block. Now it's going from right to left, so I could have the wires crossed over. It wouldn't look too good. What I can do is while the block's selected, I can right click and select format, and then I can flip it like so. Let's get the output going to the scope. The value of the gain here is 2. Remember, that's the spring constant value. And that goes like so. So that is a simulation diagram which matches this one. So let's run it for 3 seconds, see what the output is. There you go, so it should look familiar. So that is telling you that that one, the spring damper system, is the simulation diagram for the spring damper, which was example 1. So you have an option. You can either put it in as a transfer function, like that, or you can consider how it's created and put it in as a simulation diagram, but they're both the same. So you both have an input, the output, it's the same value. It's just a different way of looking at things.